Hey everybody, Mr. Parsons here, back with another math help video. On today's video, we are going to be doing this one, solving quadratic equations from lesson 9.4. We're going to be doing part 1 and 2. From the lessons, there was 4 video portions. It was a lot of lesson, although they were broken down into like 13-minute segments. On this one, we're covering questions that would be concerning part 1 and 2. So if you watch the part 1 and 2 lessons, and now you're doing the homework on it, you're doing it the best way possible. But if you watched all 4 and then you're watching this, you might want to revisit 1 and 2 as you look at this, I guess, or follow along with what I have to say and see if that helps. All right, the first couple of questions here are going to ask us to solve equations. So in the past, we've solved equations, I assume. But in the past, the way you solved the equations were, I'm just going to write something totally whatever over here. So 3w plus 7 equals 19. Like we've solved this before. We would minus 7 on both sides. We get 3w equals 12. We divide by 3 on both sides. W equals 4. Voila, we found the value of w that makes this equation true. It must be 4 because 3 times 4 plus 7 equals 19, and that's why it's the answer, right? But now we're looking at equations that have a little bit more. Now, what you're going to see very frequently on these types of problems is it always equals 0. It doesn't have to equal 0. You could have numbers all over the place. You just very frequently get 0 for whatever reason. So it says find w, where w is a real number. Round your answer to the nearest hundredth. Okay, here we go. So here's the goal. Just like I showed you a second ago, we're trying to get w by itself. So we add or subtract things. We need to add or subtract. In this particular problem, I need to add 88. 2w squared equals 88. Okay, is there anything to divide? Yes, divide by 2. W squared equals 44. Okay, now this is new. On the thing I showed you a second ago, we got w by itself. But now what we've done is we've gotten w squared by itself. That's really where this problem needs to be before you do the one additional step you need to do to make it not w squared, which is to do the opposite, right? Opposite of subtracting 88 was adding. The opposite of multiplying 2 to w squared is dividing by 2 on both sides. And the opposite of taking w and squaring it is taking it and square rooting it. So you square root both sides. This effectively causes the w squared to become just a w, and then the 44 becomes the square root of 44. Sort of. Now here's the thing. There are 2 different numbers in the world that, when squared, make 44. And you're like, what? How could even a number make 44? Because it's not even a perfect square. Well, yeah, life would be a lot better if this was like the square root of 9 or whatever. But there's 2 numbers that, when you square them, make positive 44. The square root of 44. If you square the square root of 44, you get 44. And if you square the negative square root of 44, let me show you what I mean by going to Desmos here. If I type square root of 44, that's a number. We're going to need that number actually in a second. But if I take that and square it, it makes 44, right? And if I take the negative square root, hold on a second. Negative square root 44. Yikes, that didn't come out at all the way around it. Negative SQRT. Okay, then I square that. It also makes positive 44. You're always, when you use this square root property, quote unquote, to solve an equation, and you take the square root on both sides of it, you always have to take the side that didn't already have something squared going on. The squared just loses the squared and becomes regular w. However, the side that was just a regular number you're square rooting, you get 2 outputs, the positive and negative version of that, because the positive version squared makes the number you want, and the negative version squared makes the number you want. So this is where 2 answers split up. Now, there's 2 things to keep in mind here. This is a legitimate answer. There's 2 answers. It's negative square root of 44 and positive square root of 44. Those are the 2 answers to the problem. Those are what w equals. The problem we have right now is that they don't want you to type square roots. Like, there's no square root button. I can't type and I can't do anything. It doesn't want square roots in here. Square roots are always better as an answer, as a math teacher, I can tell you right now, knowing how to write the square root answer is always best, okay? I'm going to show you something here real quick. I might not bother with all the problems, but I'll show you on this one. The square root of 44, if you do something we did early in the year where you make the little factor tree, it's 4 times 11, and 4 is 2 times 2. And there's a pair of 2's, which means we are allowed to write 2 on the outside, and the 11 that went unused goes on the inside. So 2 root 11 is the answer. And by that logic, negative 2 root 11 is also the answer. Again, it's still not possible to write that, but if you were told that you had to write it in root form, you have to write it in these two because these are the best answers. Okay? Now, you don't have to do that on your homework assignment. If you go in here and you type square root of 44, like this, you'll get that answer. And if you type 2 root 11, you get that same answer. Okay? You don't have to change it. I'm just saying if you were told to write it in the most simplified exact answer, root 2 root 11 and negative 2 root 11 are the true answers. In this case, it says round your answer to the nearest hundredth. So I'll do what Alex says and want 6.63. I don't need to round because the 3 afterwards. So 6.63, and therefore negative 6.63. Now what you're going to see as we progress through homeworks is, for now, the answers tend to be a number and then the opposite of that number. But that's not always going to be the case. In fact, that's very rarely the case, that you just have a number and its opposite as the answers. I'm sorry that if you don't like that, but that's just the way it is, as they said in that one song. All right, let's do another one. Here we go. 2u squared plus 8 equals 98. Hey, look, a number on the other side that wasn't 0. Okay, so now we go through our steps. Anything to add or subtract? Yes, I subtract 8. I get 2u squared equals 90. I divide by 2 to get rid of that 2. Now I get u squared equals 45. And now the answer will be, when I square root both sides, this becomes u, and this becomes, remember, when you square root that number, it becomes a positive and negative version of that number. So it's plus or minus root 45. So there's your answer right there. We could stop the problem and be like, okay, what's the square root of 45? Oh, 6.71, because that 8 afterward rounds it up. So I could say 6.71, negative 6.71. Done. That's the answer. Now, if you want to be a extra accurate math person, you could do this and do the little factor tree. 45 is 9 times 5, and 9 is 3 and 3. There's a pair of 3's, so the true answer is 3 root 5, as well as negative 3 root 5. Those are the true values of u. But they want the decimal, and they round it round into the nearest hundredth, so we do what they say. Cool. Now, if you did those two problems and you were somebody who also watched the lesson video, good for you. I sure hope you're not just watching my video only so you can get direct help with the homework after not having seen the lesson, but to each their own. I know who you are. Just kidding, I have no idea who you are. All right, if you watched the lesson video, though, here's what I have to say. This next problem is more like what you would have seen on the lesson. So if you were looking at what we did so far and said, that wasn't like the lesson at all, well, you're right. Because in part 1 of Mr. Steiger's lesson, he solved a number of problems that looked like this, that had a couple of things inside of a parenthesis that you have to simplify. The process is about the same as what I just did, but there's a little bit more to it, okay? So first step is you add or subtract anything you can. Keep in mind you can only add and subtract stuff that's not inside this parenthesis. The parenthesis is like locking away the v plus 3, so I can't mess with that. I can, however, minus 4 on both sides. So now I get v plus 3 squared equals 8. Now here's the deal. The parenthesis is locked, but you can take the squared off it just like we took the squareds off the letters on the last problems by square rooting it. But here what you're going to do is you're going to square root that whole parenthesis, and you're going to square root the other side. And what happens is v plus 3 comes out of the parenthesis and the square is gone. When you square root, it cancels out the squarine. So all that's left is what was inside. However, the other side becomes not just square root of 8, plus or minus square root of 8. Yes, 2 different answers on this side as well. Now, on the problems we had so far, we were done and we said, okay, the answer is positive square root of 8, negative square root of 8, and we found out what that was as a decimal, right? Well, there's actually more to do here. You can't leave plus 3 over here with v. Now that it's no longer locked, quote unquote, in the parenthesis, you can subtract 3 from both sides. Now the traditional way to do this is to write v equals this number you subtract. It can't subtract from the square root of 8 for two reasons. Number one, square root numbers cannot combine with plain numbers, okay, technically speaking. And the second reason is numbers that I have this plus minus symbol, which is a little bit new to us, this plus minus symbol can't really be combined. So what I'm going to do is I'm going to write minus 3 in front and then plus minus root 8. This is the common way to write the answers. V equals negative 3 plus or minus the square root of 8, which technically, to be honest, if you're writing this all legitimate, would be negative 3 plus the square root of 8. That's one of the answers, whatever that equals. And then the other answer is negative 3 minus the square root of 8. Okay, again, these are not the most accurate answers because if you were going for the true super best answer, you'd write 8 is 4 times 2 and 4 is 2 times 2, and there's a singular pair of 2's. So therefore, v equals negative 3 plus 2 root 2, and v equals negative 3 minus 2 root 2. Whew, what a problem, right? So here's the most accurate best answer of all. Although if you used what I wrote at the bottom down here, that'd be fine. Now here's where you got to be careful. If I go over on my Desmos here and I type negative 3 plus the square root of 8, I get that. Do not go in and write here, let me write this answer in. Negative 0.17, that's to the nearest hundredth. Do not write positive 0.17 if this was your problem. Absolutely not, because if I write negative 3 minus square root of 8, I get a completely different number. And this is what I was talking about earlier. It's not just a number and its opposite. So once you've written one answer, please do not assume that the other answer is the opposite of it. This one is a totally different number, and it's negative 5.83. I'm writing 3 because the 2 is followed by an 8, and the 8 tells me to round it up, so I'm rounding it this way. And then I check. Okay, so be on the lookout. It's very likely that you will get two different answers. They could both be negative. They could both be positive. You could have one positive and one negative. It could be anything. Okay, now technically, if you want to look at the clean answer, it's negative 3 plus 2 root 2, negative 3 minus 2 root 2. Ooh, that looks so beautiful to me, mathematically speaking. But they want us to convert that to decimals, so it is what it is. If you watch the lesson, I believe Mr. Steiger put all the answers in this exact form, not an approximation. All right, let's do another one. All right, we got v minus 5 squared minus 80 equals 0. Okay, same deal as before. If it's outside the parenthesis, got to deal with it. So I'm going to add 80. And add 80, and I get v minus 5 squared equals 80. Hooray. Okay, now we're at the point where we could square root. By the way, it's not always just like add and then square root. I know these problems were a little simplified, but I don't know what your scenario would be. But what if there was a 2 multiplying out front of this? That's not happening here. I'm just what-ifing right now. If there was something multiplied out front of the parenthesis, you would actually want to divide that on both sides to reduce stuff. That didn't happen on my problem. I'm just saying if your problem did have something outside the parenthesis, it has to go first. So we made the minus 80 go, and if there was like a number multiplying or dividing or something, this parenthesis, we would have to do the opposite of that to get it out of there too. But now that it's just a parenthesis, we can square root both sides. I'll do my arrows like I have been. V minus 5 comes out, and that's it. And then the square root of 80 isn't just the square root of 80, it's the positive or negative square root of 80. Just like the last problem, we have this lingering negative 5 here, so we got to add it to both sides. Do not add it with square root of 80. Don't make it square root of 85. That's not the same thing. The 5 just simply goes out front, plus or minus the square root of 80. So here's the rough answer. If I were writing this a little better, I'd write 5 plus root 80. And then I'd write 5 minus root 80. Whew. I got myself there. That kind of looks like an 86. Better. Okay, that's a better answer. And if I was going to write the ultimate best answer, I'd write whatever the square root of 80 is simplified, which is 16 times 5 And 16 is 4 times 4. And I could split the 4s up, but you know what? I'm just going to say 4 and 4 is good enough, because once you got a pair, you can use it up and not worry. So the real best answer is 5 plus 4 root 5 and 5 minus 4 root 5. Those are the best answers. Again, you don't have to go that far. Yeah, you don't actually really have to go much further than 5 plus or minus the square root of 80 over here, because what you can do on a calculator is 5 plus square root of 80. So let me write that answer in, 13.94, and then 5 minus. Now, I'm writing it on 2 lines. If you're lazier than me, I guess you could just change this plus to a minus. There you go. Negative 3.94. Double check. It would be a real shame to, at the end of this problem, get it wrong by missing the rounding. They all say round to the nearest hundredth, it would appear. So make sure the second decimal is what you write. But don't just stop there. Check to see if it needs to be rounded. On these two, they both follow via 4, so no need to round here. Hooray! All right, new problems. Hooray! We finished the part 1 questions. The 4 things we did right there were all part 1, and this was called square root property because every problem was solved kind of like the linear stuff we did way earlier in the year, except for we needed to do a square root step, which caused a little bit of a mess and made it 2 answers split out, right? Okay, that was all part 1. Part 2 is this thing called the zero product property, and I hope you're watching this. If you're watching this video, hey, good job, thank you. If you're watching this video and you're doing this before you're doing part 3, you're doing it right, because I don't know how you will have a great time with part 3 if you don't look at this part 2 stuff. And this problem 5 to the end is all part 2, called the zero product property. And the zero product property says this: 3y plus 5, 7 plus y equals 0. On the previous problem, when we were solving for those letters, or I guess whenever the thing says solve, what we're trying to do is find out what number you plug in to make it true. On the last problem, it was literally the answer was 5 plus the square root of 80. That is a value that if you had plugged it in for v, would have made the original equation true. And 5 minus the square root of 80, if plugged in for v, would have also made the original equation true. Now the question is, what do I plug in for y to make this equation true? Well, it looks like a lot. It's all factored and stuff. And please, oh my gosh, do not attempt to distribute. Don't start drawing arrows and doing 3y times 7 and all that stuff. Don't do that. Because all you're going to do is make it worse. Factored is good. You want it to be factored. That's why you should do this before part 3, because part 3 is where it's not factored and you got to make it factored. So it's nice that it's factored. So the zero product property states this: if this first parenthesis is somehow equal to 0, then who cares what's in the second parenthesis? Like if I find the value for y that I plug in and multiply to 3 and multiply, if there's some number I plug in right here and multiply to 3 and add 5 and it makes 0, who cares what's even in the second parenthesis? 0 times whatever this equals after I plug in a number equals 0, right? Same thing for the second parenthesis. Whatever I plug in here, if I make 0, who cares what the first result was from me plugging in stuff? It doesn't matter, because if the second thing is 0, something times 0 equals 0. And that's very important. When you do these problems, you're going to see 0 on the side. So that's how you should approach it. You should say to yourself, how do I make each set of parentheses equal 0? So it's like solving 2 mini problems. Mini problem 1, how do I make this equal 0? Because if this equals 0, the whole problem is 0. Problem number 2, if this equals 0, then it all equals 0. So you have to solve 2 little problems. Now the good news is, let's start with the second one. It's easy enough to do, right? I subtract 7 on both sides. And y equals negative 7. That's literally one of the answers right now. Yes, it's not decimals anymore. For now. So here's the deal. Think about it. If I plugged in negative 7 to y, 7 plus negative 7 is 0. If I plug in negative 7 over here, it's not going to make 0, but who cares? This could be whatever. Technically, it's going to be, negative 16? Negative 16 times 0 is 0, right? If I plug in negative 7, the second parenthesis becomes 0, and therefore the whole problem equals 0, and therefore it's a true answer because we want to make it 0. So negative 7 is the answer there. The second one here, I need to subtract 5. So I get 3y equals negative 5, and then I divide by 3. And we're done, actually. Don't actually divide 5 by 3. Just leave it as a fraction, negative 5/3. It's okay if you write a fraction. If you want to make it negative 1.66 repeating, don't, because Alex won't like that. They probably want you to put an accurate answer. So leave it as a fraction, okay? Now here's the deal. When you do these problems that are pre-factored, or even the ones that you'll do later that are factored, you have to probably get used to doing this like quick-ish. Like you do not want to sit here and write out this work every single time, right? I think after having seen the problem, a person viewing this would say, oh, 7 plus y. I write the opposite, negative 7. That's the answer, right? And can you tell that the first parenthesis set kind of had an answer related to the numbers that were in it? The quick way to answer this is simply whatever the opposite of the lone number is, the opposite of that, divided by whatever's in front of the variable. So in this first parentheses case, the opposite of positive 5 is negative 5, and I put that over 3, the number that was with the variable. So you could answer it quickly. I'll say what I mean by that when we see the next problem. Make sure when you write your answers, you write both answers separated by a comma, because that's what the instructions say. So negative 5/3 and negative 7. Okay, let's do another one. So here's what I mean. This one's a little trickier. Looking at the problem, see how it says 2 minus u? Well, what would u have to equal to make 0? The opposite, well, it's because a minus sign's kind of screwing with things, but 2 minus 2 is 0. So I can tell you right now, one of the answers is 2. Simple as that, right? And then I'll use my logic from the other one. The opposite of the lone number, 6, so negative 6, over 4. So the other answer is negative 6 over 4. Now, to be honest, it won't be happy if you write negative 6 over 4. It's negative 3 over 2, because you have to reduce it if you can. But here's the deal. If you're like, no, what? How do you get that, Mr. Speed Guy? All right, I'll show you what's up. Set each individual parenthesis to 0. So the first thing equal to 0. Second thing equal to 0. Now you solve the two problems. First I minus 2. This is negative u equals negative 2. That is not solved. You can't leave a negative on the u, so you divide by negative 1, which makes u equals regular 2. Which is what I said was the answer, of course. You can use a little mental math. If you can solve these with mental math, good. That's what you should be able to do. I assure you that when you get to higher math levels, you will need to know how to solve stuff like this mentally, at least after it's factored. So here, I divided by 4, negative 6/4 reduces to negative 3 over 2, because I take half of each of those. And therefore, those were the answers. Again, if you can see what the thing that would plug in to make 0 is, write it. You don't have to like go crazy here. Here, let's try it on this one. I won't even write stuff. 2 minus z. Well, I already know that because I was in the last problem. Dedoy. 2 minus 2 makes 0. So there's the answer based on the first parenthesis. And the second parenthesis, it says negative 6. So I'll write the opposite of that. Positive 6 over 5, the number that was with z. Simple as that. It's mental math. It can be mental math if you want it to be, okay? All right, back to some problems. Now this is where we're gonna spice it up, and you'll see what I mean. On the previous stuff that we were solving out, we saw two different things. We saw factored things, and we saw things with variables in it, and we had to square root, right? You can't do either of those things here, really. Like, so here's what I mean. It's not factored, right? There's not stuff in parentheses, so I can't really use that zero product property yet. And it's not like the first ones where I can get v squared by itself, because there's this other v here, and it's not good math practice to push that to the other side and do stuff with it. Not a good idea. So here's what I'm going to do. You should look at this and say, okay, what can I factor out? Like, what is divisible here? Well, they're both divisible by 5, right? 5 and negative 20 are both divisible by 5. Additionally, both of these terms have the letter v. So what I'm saying is I can take 5v out of these. Well, what do I get if I take 5v out of these? The first thing just becomes v. Would you agree that if I redistributed 5v times v, you get 5v squared? Okay, that's the point. How about negative 20 divided by 5v? You would be left with a negative 4 and no v. And this equals 0. So what I've essentially done is I've divided out what I could. And they were both divisible by 5. They were both divisible by v. So therefore 5v goes on the outside. And the leftovers, v and minus 4, stay on the inside, right? Now you can use the zero product property from the previous problems. What goes in here to make 0? What goes in here to make 0? Yeah, it's not in a parenthesis, but you can still treat it like that. In fact, if it makes you feel better, put a parenthesis around it. I don't care. What makes 5v equal 0, and what makes v minus 4 equal 0? I hope v minus 4 is easy enough for you. It should be 4, right? 4 minus 4 is 0. But if you want to solve it by adding 4 to both sides and confirming that v does indeed equal 4, that's fantastic. On this other one, you're technically wanting to divide by 5, and 0 divided by 5 is 0. Here's the short version. If you have something like 5v on the outside, or 5x, or just x, or 10x, if you have something on the outside and it's just a single monomial term like 5v, the answer to that is 0. You don't actually have to work it out, but I worked it out here. 0, 4. Check. So what I had to do was this. I had to factor it. I had to do a little factoring myself, taking out the greatest common factor. And then the leftovers, I use the zero product property to decide what went in there to make 0. Now, after you factor it, you can probably visualize it. I will try and show you that on some of these other problems, okay? So we got 3x squared plus 21x equals 0. What can I divide these both by? Okay, just like the last one, they're both divisible by 3. And they both have the letter x in them. Please don't get confused. What I see some people doing when I observed this in school was they saw 3 and 21 and instantly started writing like 7 because you're like feeling like these are related by 7 somehow. And they are, but please remember, what can I divide each of them by? 3 is divisible by 3, 21 is divisible by 3. So please write 3, and they both have the letter x. Now the leftovers are x plus 7. That's where the 7's coming into play. I know you're thinking about it, so there it is. There's the 7. Whoop, whoop, that's a 0 up there. That's a crazy 0. All right, now that I've got this, I can write my 2 answers. But wait, you said, you didn't solve them individually. Ooh, guess what? The first thing, 3x, like I was mentioning, that's a 0. If it doesn't have anything added or subtracted after the 3x, and it's just like 3x, the monomial, put 0. And then the second one, we can use our mental, logic. What goes in here to make 0? Negative 7, right? Negative 7 plus 7 would make 0. And again, what are we even finding, right? Like, well, why am I getting 0 and 7? Because if I plugged in 0 to the original equation, 3 times 0 squared plus 21 times 0, I would get 0. If I did negative 7, 3 times negative 7 squared plus 21 times negative 7, that would in fact make 0. Yes, I know. Negative 7 squared is 49. 49 times 3 is 147. 21 times 7 is negative 147. And positive 147 and negative 147 make 0. Okay, so just saying, if you plug in the numbers that you get as the answers, that's because they make it true. Hopefully we're starting to get the gist of these here. Same deal on this next one. Unfortunately, almost the same deal on this next one. And by that, I mean they're both divisible by 3, and they both have the letter v, which leaves us with v minus 5. And again, use our opposite. So the 3v means one of the answers is 0, and equals 0, v minus 5, that's a 5, right? Oops, put a comma between them though. 0 and 5. Ta-da! If you're noticing, when you have quadratic stuff, and by quadratic stuff I mean things with squared as an exponent, you're going to get 2 answers a lot, very frequently, okay? There are cases where you might get 1 answer, and there are cases where you might get no answers, but we haven't talked about exactly how that looks yet. I will say this, in regards to everything we've done today. If you are ever solving a problem and you are asked to take the square root of both sides, but the number you're taking the square root of is already negative, that's bad. I'm gonna make it red here. No, you can't do that. You can't take the square root of a negative. That's no solution. So, wow, writing the word solution. Solution. All right, so just so you know, if you're ever doing this and you're asked to take a square root of a negative, that's actually no solution. So that's why on some of these problems, if I were to go back to the beginning, I believe it had no solution as a suggestion, right? If there's no solution, click no solution. The situation in which you would get no solution is if you're asked to take the square root of both sides, but the number side is already negative. There is no number that when you square it makes negative 49. 7 and 7 make 49. Negative 7 and negative 7 make positive 49. But nothing in the world times itself makes negative 49. It's impossible. Well, nothing in the real number spectrum. There's imaginary numbers, but that's an algebra 2 thing. Okay? So that's when you would see no solution on any of the stuff we saw today. On these ones that are factored, if they're factored, they almost certainly have a solution. The only time you would see one solution is if it was factored, but it had like two of the same thing. So let's say you factored it and you got x plus 4, and you got a second x plus 4. That's obviously very rare. You don't see that very often, but in this case, the answer would be x equals negative 4. And on the second one, the answer would also be x equals negative 4. So you would just write the one answer of x equals negative 4. So just so you know, as you're doing these quadratic equations, you're solving them. There's going to be more of them, okay? This whole chapter has got a lot of them. You usually have two solutions. It could be one positive, one negative, two negatives, two positives. It could be crazy decimal numbers. It could be whole numbers. It could be fraction numbers, rational numbers, let's say. You could have no solution, okay, in some cases. Very, very rare, but, you know, possible. And you could have one solution, and the one solution would be if you have like something doubled up. Okay. All right. I'm gonna hit submit here. It's a long video, but I'm not quite done. I just want to review everything on my report, as is tradition. So for the first few problems, we solved them by adding and subtracting things to both sides, dividing things on both sides. Then we used square roots to simplify the square out of the problem, although that caused two different answers to appear. On the first two problems, the way it was set up was that we got an answer and it's the same thing but opposite. That was simply because the first problem didn't contain any parentheses. When you start adding in parentheses with a number inside of it with the variable, then after you've square rooted both sides, you have to add or subtract some number to both sides, which causes some variation in the two different answers you get there. So we had 4 problems doing the square root property as solutions. Then we did a whole bunch of problems doing the zero product property. I really want to make sure we're good at those because we have to do a lot of that in the coming up assignment. So this one was simply, how do you figure out what goes into each set of parentheses that would make it 0? So like the opposite, right? Negative 7. Here it's not really the opposite. It's kind of like opposite of the 5 over that other number. So we did a little bit of that. And then we got down to these later ones. I'll just use 9. And these ones we had to actually factor it first ourselves, then use a zero product property to answer them. If you're sitting here at the end of this video saying, man, that was confusing, well, it ain't easy, man. Nobody said factoring and solving quadratic equations easy. In fact, quadratic equations is what I'd probably consider like the pinnacle topic of Algebra 1. Like, this is as Algebra 1-y as it gets. Everything else in the year was kind of just leading up to how do we solve this kind of stuff. And you will be asked to solve and factor this stuff throughout high school. Algebra 2, you'll use it in geometry. You will factor quadratics in Algebra 2. If you do pre-calculus, you're going to be factoring there too. Now, we haven't got to the crazy factoring yet, or I should say the applying chapter 8 to this chapter yet, but we'll do that on the next lesson, the next homework help video from lesson 9.4, part 3 and 4. Okay, I appreciate you watching, and I'll see you on the next one. Thanks.